to your next challenge entitled Replace Letters with Position in Alphabet. Create a function that takes a string and replaces each letter with its appropriate position in the alphabet. A is 1, B is 2, C is 3, etc. Look to the examples below. We get the input, wow, does that work? And we have the letter numbers. You can imagine W is 23, that's reasonable. O is 15, again 23 for a W. Notice it goes right into 4 to take the letter D. So we're ignoring space and punctuation. It looks like it's going only for the letters. And you can continue to make sure that 15 is O, 5 is E, all you like until you're convinced or that you understand what they're asking you to do. I don't think the other two examples shed any extra light, so I'm going to proceed to the coding section. I will mention the one note. It says if any character in the string isn't a letter, ignore it. And we kind of mentioned that already. We only care about letters. So I'll go over to code now. Please pause the video and do your implementation first and resume when you're ready. So my idea for this problem, I'm going to use the regular expression class to filter out all characters that aren't letters, since all I care about here are letters. And then I'm sort of going to make a new string out of that with just the letter content, and then iterate over that collection. And from there, I'll examine each character, and I'm going to use its ASCII value as a means of getting the letter indexing right. So I have a chart of ASCII values here, and you can see that the letter A, let's go with lowercase a, we'll make the whole string lowercase just to keep it the same. Notice they used in their instructions, let me show you, they used 23 for both uppercase W and lowercase w, so they really don't care about capitalization here. So anyway, back to this chart. A is going to be 97, right? So I'm going to note this value. Then what I'm going to do is anytime I encounter a letter, I'm going to grab its integer value, which is this ASCII value, and I'm going to subtract 97 from it to get its letter number. So notice if I had the letter A, I subtract 97 from 97, that leaves 0. And then I'll add 1 because they wanted 1-based numbering and not 0-based. So if I got the letter C, I would have 99, I'd subtract 97, that leaves me 2. I add the 1 for the 1-based numbering, and I get 3. And you can see how that works out the way we would want it to. So that's the general strategy here. Like I said, I'm going to just convert this thing, let's call it lower string, since we don't care about case at all. Excuse me. So that problem's out of the way. Then I said I wanted to basically remove all of the noise. We only care about the letters, right? And we've used regex for this in the past. So hopefully you can do that now, or hopefully you remember it when you see me do it. I'll call it string, let's call it letters only, and that will be equal to the regex class. We had that replace method that takes 3 strings, if you recall. Our input, well, remember we're using lower now. Then it takes a pattern to search for, and we know that A to Z and capital A to Z cover all of the letters. And we've also learned that if you use the caret symbol at the beginning of these regular expressions, it basically says the negation. So this phrase right here, this regular expression, will match everything that's not a letter. So I said all letters, and then I put not. I negated it, so it grabs everything that's not a letter. And then I just want to replace that with an empty string with nothing. That'll essentially remove everything out of there. So we should have letters only at that point. And then I'm going to use this string builder class that we used once before. And this is just a more efficient way of sort of modifying strings. You don't have to do it this way, but I'm just going to bring it in again just to reinforce the concept. And it's often useful. So at this point now, I can iterate over my filtered input. Let's go letters, sorry, I is less than letters only dot length plus plus I. This will grab each character in there. Now, at this point, we know everything's a lowercase letter. So I don't have to check if a character is a letter. I can skip a lot of that sort of nonsense, right? But I did mention the ASCII technique that I was going to use, and to that end, let me do it the right way and make a constant for this. So we can call it, we'll just say private since it's in here, static read only. Let's call it ASCII A. I should put the type in there too, int. And we saw from the chart that was 97, right? So this is going to help us. We'll refer to this value. So what we do is we grab this will grab the current character in our string that only contains letters now. So this grabs the current letter, and we said we were going to subtract this constant from it, and we had to add 1 because it's zero-based numbering, right? And then to make this work properly, I think I should cast this to an int, because remember, letters only is going to be a char. It's a string. So if I grab an index of a string, it's going to be a char. I'm converting it to an int, which will turn it to that. It'll give us that ASCII value of the character, and then I can do the subtraction like I want to do with all integers. So we've got that. Now I want to take this value, right? It's the letter of the alphabet now is what we have here, and I'm going to add it to my string for each loop. And then if you notice in their instructions, they had spaces between all the letters, except for the last one. So we're going to do something for that too. I'm going to say if I is less than letters only dot length minus 1, meaning it's not the last element, then we're also going to add a space. Right? And if you want, I could print out the characters there if you wanted to see that working. Why not? Console, right line. This will be the, let's call it letter number. And this will be this value. My console right line sort of statement here is just temporary. Otherwise, I wouldn't repeat that. I would break it out into a variable. But it's just to help people visualize, see the letters coming in. So, what else do we got here? I don't know what happened here. Was there an extra paste? Anyway, that should be fine. And then finally, once all the characters have been processed, we can say return SB to string. Remember, our function signature said to return a string, and the toString method of the string builder class will do that. So let's give this a run. Oh, you know what? We're going to get a lot of problems here. We're using all these outside classes. Do you remember the using statement for rejects? Say it now. System.text.regular expressions. Then we should probably need one for string builder. We're going to need one for the console write line statement, let's say system. And I think for string builder it's system text, but we'll find out if I mess that up. Let's try running this, see what we get. Cool. Yeah, you can see all the letter numbers being printed out here. And what I should have done, actually, let's copy this, refresh. I'll put a little bit better. Oh no, did I really just do that? Ugh, yuck. Hold on, I think I got it. I totally hit Control C and copied over what I had copied before. So let's do it this way. Okay. This way you can see the character and the ASCII value. So this statement should that way you can kind of see the for our second value here. We'll do it this way. We could do three statements. You can see the character found, the ASCII value, and the letter no. And then we'll take this statement. And see how I'm passing in just the character. This is gonna, or no, this will be okay. So yeah, I'm taking the character, how does it say CH? I think I gotta place that. Let's take filtered text I called that letters only before. Here, we'll do it easier. Char filtered text I. Give us a nice little shorthand. So you can see letter, you can see what happens when you convert the char to an integer with this casting, and then finally you can see the whole process where we subtract out the ASCII value and add 1. Alright, let's run this. So this output statement hopefully makes it a little more clear what was going on. Notice it was lowercase to start because we did the 2 lower. The original input had upper, but we don't care about casing. So you got W, it tells you its ASCII value. If you subtract 97 from that and add 1, it should come out to 23. And you can see all these integer values corresponding to the letters position in the alphabet being printed out, and that's essentially what we're adding to our string builder, and then adding a space between each of them when appropriate. And you can see it's quite a long statement. But yeah, hopefully that print statement makes it a little more clear what the algorithm did. So, as usual, please share your solutions or any questions you may have. Otherwise, I'll see you in the next video. Thanks.